weapons of mass destruction. Oh, you guys, are you ready to be put asleep?
No, let's do this.
Can I draw a picture that's so darn familiar? I hope you fall asleep. I hope you do. Oh, hold on, I didn't leave myself enough room. So there's a graph equation, y equals f of x. And here's a graph equation. Y equals g of x. And if you guys don't mind, let me go ahead and look at two positions in the x-axis. I'll arbitrarily refer to them as A and B. And now let me tell you what my goal is. My goal is to determine the exact area, not under one of those curves, but the exact area in between those two curves. So what I'm going to do is create a regular partition of the interval from A to B. When I use that word partition, I simply mean I'm subdividing the interval into smaller parts. When I use that adjective regular, I'm using the same way you guys did back in high school geometry. I just simply mean each of those subintervals is going to have the same length. So, allow me to do it. If you guys don't mind, I know I put A in the board, I'll rename it. I'll think of that as how about an x of naught? How about this is x of 1? This is x of 2. How about all the way down to the I subinterval? X of I minus 1, x of I. And all the way down to the last subinterval, say x of n minus 1 to b, which I'll refer to as x of n. There's my regular partition of the interval from A to B. Next, let me go ahead and choose an arbitrary value of x in each of those subintervals with my blue pen. Can I think of this as z sub 1? This as z sub 2. This as an arbitrary value of x chosen in the ith subinterval, I'll call it z sub I. And maybe even down to the last subinterval, arbitrarily choosing the value of x in there, I'll call it z sub n. Now, I don't know where these z values are coming from specifically. They're just somewhere in each of those subintervals. They may be left endpoints, right endpoints, midpoints, or how about none of the above? In each subinterval, I might be choosing a different value in terms of its relationship between the endpoints. Don't really care. Here's what I could do. At least over the first subinterval, to approximate the area in between those two curves over that first subinterval, I'm going to use this blue value of x, I call it z sub 1, to determine the corresponding y values on both these two curves. And then use the difference to generate the vertical height of my first approximating rectangle between those two curves, at least over that first subinterval. Now over the second subinterval, I would choose this x value in blue, I call it z sub 2, to compute the corresponding y values on those two curves and use those y values to determine the height of that next second approximating rectangle. And over the last subinterval, playing exactly the same game. Choose the green, or the blue, excuse me, x value to determine the height of that last approximating rectangle. Oh shoot, I missed one. How about the arbitrary height rectangle? Looking at these two y values, here's the corresponding image of that rectangle. And if you guys don't mind, I'm just going to take a quick break and compute. Oh, I need to get rid of this. I said compute the area of that ith approximating rectangle. And I think the area of that ith approximating rectangle is going to be nothing more than the height times the length. But the height is nothing more than the difference between f evaluated, I heard that, z sub I, minus g evaluated at z sub I. Oh shoot, I made a mistake. That's just a height. I want the area, so I better take that height and multiply it by. Don't waste Bradley's pen. Thank you, I heard that. The horizontal length of that I-sub interval, which is nothing more than delta x. And by the way, in my picture, you guys know what delta x is. I said, you guys know what delta x is. I can say it 3 times. I guess I'm not putting it to sleep, am I? B minus the length of the whole interval divided by how many subintervals I considered. I agree. Oh, I still haven't answered the question. Darn it! I wanted the actual area in between those two curves. And I think the actual area between those two curves can be approximated by summing together as I ranges from 1 to n. The area of those individual n rectangles. But I think I can get the exact value for the area in between those two curves by taking my approximation, but taking its limit as n increases up and down. Or shall I say, the exact area can be considered the limit as n increases without bound of the sum as I range from 1 to n of my function f evaluated z sub I minus my function f evaluated, I said f, I meant g, evaluated z sub I, and multiplied by the horizontal width of each of those rectangles. It's just that when I take the limit of this Riemann sum, I can rewrite this as a definite interval. By definition of definite intervals. And I'm merely left with the integral from a to b of my f of x minus my g of x, and I'm integrating with respect to the variable x. Shoot, look what I've just done. In a mere 2 small ink bores, I've demonstrated a technique for you and I compute the area between those two curves. Now you can say I wasted your time. You could have just said, gee, let's just look at that integral all alone. That's the area from f down to the x-axis. Drop it like a rock. Look at this integral. The area underneath g down to the x-axis, drop it like a rock. And then look at the difference of those two integrals. But the difference of two integrals, assuming the bounds are the same, is the integral of a difference. So I guess I could have generated all this the same way, in a different way. But I am shaking you up. When I took a roll the first day of class and found out we're coming from all over the place, so I want to make sure we're okay with our fundamental definition of definite interval. David?
Are we going to be tortured with the good old-fashioned definition way of doing it, or can we just jump straight into the...
Shoot. Hold it. I got to think about that.
Don't think. Just say no.
I just don't have an opportunity to do that.
Oh, excellent.
I just don't have an opportunity. It's sort of like this. Now that you wonderfully experienced that definition of Math 30, now we're really just using shortcuts. So I'm not going back to
still study for the exam.
I don't know. Should we?
Should we what? I'm sorry.
Still study it for the exam?
You know, I'm being honest. I just have no opportunity to slip it in a legal fashion.
Okay.
It's sort of like me asking you this. Quick, what's the root of x squared?
2x.
Yeah, that's fast, because you use the power rule for differentiation. As opposed to me asking you, use your definition of derivative. Think of it as limit of the difference quotient. Like that's the h minus f of x over h. You know, at this point, we just have to short.
Excellent.
I was afraid you'd say that. You guys, I can't do anything in 3 minutes. Can we just take a break early? Oh, so sorry, sir.
Very quick question. I lost you at what a sub I was. I mean, I know you can take the infinite sum of it and then get the thing.
Sir, because I did a poor job on labeling. I didn't label the a sub I. I said it out loud in English, but I meant a sub I to be the area of the rectangle over the I sub interval. So the area of that rectangle is my a sub I.
I see. Okay, it's not like the area between 2 points, right?
Correct, it's not. How about this in English? I'm referring to a sub I as the area of the rectangle over the I sub interval. And you have to confess in my picture, not bad. I think the height of this rectangle is just f evaluated at the blue beast minus, well, g evaluated at the blue beast. That's the height of my rectangle, but it's horizontal length. It's just a small change in the x direction. And that's exactly why I said, oh, a sub I is just another name for all this garbage right here.
And the smaller that delta x is, the finer your rectangles are.
I agree, the smaller the length of the horizontal subinterval, the smaller delta x is, the better approximation that approximated rectangle is to the actual area between the two curves over that particular subinterval. I agree. Anybody else want to shake me up on this? Please. That was overly kind of you. I'll get some new ones right now. Can we take our 10 minutes, guys?
Yeah.
Oy, oy, oy.